All right, welcome back. Prep Station, UTME 2025 Physics. All right, so we stopped at the reading accuracy for meter rule, okay? I told you how we got plus or minus 0.1. In case you did not get that, let me say it again. Reading accuracy is what? The smallest possible value that can be measured by what? A measuring instrument. I just explained why meter rule is 0.1, because the least smallest value here is 1 millimeter. And then by conversion, 1 millimeter is what? 0.1 centimeter. Now, what about vernier caliper? Vernier caliper can measure, dimension even more smaller than what? The meter rule, okay? So it's used in measuring is sometimes external diameter, mostly the diameter of cylinders. So vernier caliper is used in measuring the diameter of round objects, because meter rule cannot do that precisely. So it's used in measuring diameter of round objects. It can be external diameter. It can be internal diameter. Sorry, I did not put the diagram here, okay, to show you the image of a vernier caliper, but it's a very simple device you can easily see in the laboratory and even on net. It has two scales. Vernier caliper has two scales. Number one is called the M scale. M scale. The M scale is just like the meter rule. So vernier caliper is the incorporation of two scales. One M scale, which is just like the meter rule, and then the second is called the V scale. V here stands for what? Vernier scale. The vernier scale is divided into 9 divisions, depending on the size of the vernier caliper. But whatever be the case, the reading accuracy of vernier caliper is 0.01 centimeter. That means it can measure a dimension less than 1 millimeter. How? Now, for example, if you are doing your measurement and your measurement falls in between two lines, let's say in between two lines here. In between two lines here. Now, it will be difficult for you to determine what could be the accurate value in between these two lines that make up, the dimension on the meter rule. But if you are using a vernier caliper, because of the vernier scale will give you the dimension of that one in between. So it measures more accurately than the meter rule. All right, let's move forward to another instrument. Okay, that is vernier caliper. The last on this list is micrometer screw gauge. Micrometer screw gauge. It looks like a G clamp. Micrometer screw gauge looks like a G clamp. If you have seen a G clamp before, okay, it's something like this, micrometer screw gauge, and then it has this, this is called thimble ratchet, it has adjustments, and then it has this also, the spindle. So the object probably you want to measure is sometimes the diameter of ball bearings, smaller diameter of object like ball bearings, okay? So it has a scale here which is called the M scale, main scale. And then on this handle, this cylindrical handle, it has the V scale. But the most important thing I want to show you on this is the reading accuracy of what? Of micrometer screw gauge. And what is the value? Plus or minus 0.001 centimeter. Plus or minus. So everything I've just given to you here are instruments used for measuring just length. So these three, meter rule, so summary, meter rule, vernier caliper, and micrometer screw gauge. Micrometer screw gauge. These three are instruments used for measuring length. So let me do this as summary. This is plus or minus 0.1 centimeter. I want to believe you should be able to grab this now. This is plus or minus 0.01 centimeter. Follow the order. This is 0.1. This is 0.01. And then this one is 0.001. I want to believe you'll be able to remember this, okay? So all of these are instruments used for measuring length. And we have instruments used for measuring other instruments too, like mass. You have the lever balance, you have the die balance, you have the beam balance, you have the triple beam balance, okay? So let's move forward and see what else is there. All right. Having gone through the lesson, it's time to assess ourselves, okay? Let's see if we have really learned something. So we just go through like few questions, about 10, just to check what we have learned, okay? Past questions for lesson 1. So what was the lesson 1? Lesson 1 was about measurement and unit. So let's quickly go through some past questions from UTME. So this is question 1, 2024. The degree of precision of a vernier caliper is what? The degree of precision of a vernier caliper is what? Now, what did I tell you? I gave you 3 instruments. Number 1, I gave you meter rule, right? I gave you meter rule, and then I gave you vernier caliper. I gave you micrometer, screw gauge. And what did I say about the reading accuracy? 0.1, 0.01, 0.001. So with this, what do you think is the answer to this question? The instrument we are talking about is vernier. So the answer is 0.01. So that means this will be the answer. For what? For the precision of a vernier caliper is 0.01. Want to believe you got that? So let's look at another question. Okay. 0.01, that's correct. Let's move to another question. Question 2, what is the least possible error encountered when taking measurement with a meter rule? Now, pay attention to this. The pattern of this question is different from the first one, but all is channeled towards what? The reading accuracy. So for those preparing for exam, just be mindful how the question will come. All is towards what? The reading accuracy. Now, what is the least possible error encountered when taking measurement with a meter rule? I told you, each of these instruments, why we have that sign plus or minus, it means it's either you are adding or you are subtracting while measuring. So the least possible error encountered when taking measurement with a meter rule is what? From what I displayed before, that should be 0.1 centimeter. Okay? That should be 0.1 centimeter. It's a very simple question. Let's move. Question 3. Which of these is a derived quantity? This is very simple. Now, what are derived quantity? They are dependent. They are not independent. They are dependent on what? The fundamental quantity. They are not base. So if you look at this, kilogram is a base. You can't derive kilogram. Okay, that is for mass. Meter is base. That is for length. Second is time, is base. So the only one that can be derived here is Newton. And now what is Newton? That is force, right? Newton is force, is the unit for force. And then what is force? Force is simply mass times acceleration. So with this, it means the answer is what? Newton. I hope you got that. So let's see what the answer is. Okay, yes. So the derived quantity here is Newton. Let's move. Question 3. We have about 10 to consider. Which of the following readings cannot be determined with a meter rule? Which of the following reading cannot be determined with a meter rule? I drew the diagram of a meter rule before, and I told you each line there is a calibration that represents 1 millimeter. So 2.25, you can determine it easily. Yep. 2.5, you can. 2.05, you can. So the one that will be difficult to determine is 2.56 because you cannot tell exactly where this additional 0.01 will be coming from. It's only vernier caliper that can give us this reading. So the difficult one here is 2.56. Hope you got that. All right. So let's move forward. Question 5. The internationally agreed system of units, SI, for physical measurements are what? I told you at the beginning of this lesson, the unit for length, the unit for mass, the unit for time. So if you look at all of this, Kilogram, fine. Centimeter, no. Second, fine. So this cannot be. Centimeter, fine. Grams, no. Second, yes. So this cannot be. Let me jump. G, M, and second. This cannot be. This is in pound, feet, second. So the correct answer here is kilogram, meter, and second. Kilogram, meter, and second. Hope you got that. Let's move forward. Question 6. What is the least possible error? See, different pattern of, asking this question. What is the least possible error encountered when taking measurement with meter rule? We answered that before, just that this has been twisted. Okay, so what is the answer? Now, there is a twist in the option. Remember what I gave you. I said plus or minus. I said plus or minus 0.1 for meter rule, plus or minus 0.01 for vernier, and then plus or minus 0.001 for micrometer screw gauge. Now, all of these are represented in centimeter. So the question is about meter rule, and this is the value for meter rule, 0.1 centimeter. Unfortunately, the answers are not in centimeter. So what do? Convert this back to millimeter. How do you convert centimeter to millimeter? Simply multiply this by 10. So if you multiply 0.1 by 10, you are going to get what? 1. So the answer to this question is B, 1.0 millimeter. Hope that was simple enough. 1.0 millimeter. All right, let's continue. 4 more to go. What is the least possible error in using a rule graduated in centimeters? The same question, but different pattern. Okay? What is the possible error used in a rule graduated in centimeter? All right? As you can see, the least possible error is what? Is in centimeter. You should know this by now because I've played around this question for a long time. Okay? So the answer is 0.1 centimeter. Let's look at 3 more. Which of the following quantities has the same unit as the watts? Okay, I will need to do a little derivation here. Which of the quantity has the same unit as watt? Now, watt is the unit for power. Watt is the unit for what? For power. And how do you define power? Power is simply energy. Just follow me, over time. I need to do this in case you see any other question of this nature. Now, what is energy? Energy is the same thing as work, and work is force times distance over time. So we can start from here to play around this. So let's quickly go with this. Now, what is force? Force is kilogram in terms of unit, mass times acceleration, meters per second squared, and then times. Unit for distance is meter. Then over the time that is here. The unit for time is second. Now, separate this. So that means we have kilogram meters per second squared, which represent force, then times meters per second, which represent velocity. So with this, what do you think is the answer to this question? D is the answer. So the quantity that has the same unit as watt is force times velocity. I just derived that for you to see. Force times velocity. So let's see if our answer is correct. Yes, force times velocity is the answer. All right, let's look at 2 more. The external and internal diameter of a tube are measured as these. Okay, determine the percentage error in the thickness of the tube. Determine the percentage error in the thickness of the tube. The answer is 9%. How do I show you that now? So all you need to do, come back to this, look at this value. There you have 32, plus or minus 2, you have 21, plus or minus 1. So this is what you do. Add 32 to 2, that will be 34. If you add 32 to 2, that will be 34. Then minus. Add 21 to 1, that will be 22. So 34 minus 22, that will give you what now? That will give you 4 minus 2, 2, 3 minus 2. That will give you 12. Okay, I'm not on my calculator now. 4 minus 2 is 2, 3 minus 1 is 1. Now that is for addition. Go back again to the same number. 30 minus 2 is 30. Minus. Then 21 minus 1 is 20. So this will be equal to 10. Okay? So the difference between these two, by the time you continue to work on it, then you arrive at the answer 9%. Okay? So the reading accuracy for this is 9%. Let's move. And then the last question. Okay, 9%, that's correct. Now, which of the following is the dimension of pressure? Dimension of pressure. All right, so the dimension of pressure, to know the dimension of pressure, go back to the formula. Okay, the answer is already there, but let me just show you. Okay, few minutes, let me just show you. Dimension of pressure, the unit is Pascal, and the derivation is force over what? Area. So if I continue to play with this, I will arrive at this answer. All you need to do, get the units, and then you get this. Thank you so much. Let's have a short break.